Hello, everybody. This week we're going to be talking about system performance monitoring and backup and recovery within Windows. Now, when we talk about system and performance monitoring, what we're talking about is trying to pinpoint if and when we have something we call bottlenecks in our system. A bottleneck is a portion of the system that is running slower, significantly slower than the rest of the system, and as a result is slowing everything else down. Now, a computer system is made up of a number of individual parts, and they all have to be running together roughly at the same speed if you want to actually have a seamless machine running. Now, that's what I mean by seamless is you don't notice waiting for anything. When you click on something to open it up, you double click, it takes a second, then pops up, right? Well, when you have bottlenecks, it generally causes some sort of slowness on your system. And depending on where that slowness is coming from is going to change how we try and alleviate, how we try and fix the slowness. And so that's what bottlenecks are. And performance monitoring generally is designed to address that, to try and figure out where the bottleneck is and see how you can fix it. So we're going to talk about 4 different places in the system that you can have bottlenecks. The disk drive, memory, RAM, the main memory of the computer, the processor itself, CPU, and network access, whether it's wireless or wired Ethernet. So those are going to be the 4 places that we're going to focus on. So for a disk itself, for disk drives, nowadays half the computers out there don't even use mechanical drives anymore. They're using solid state drives, which are significantly faster, much, much faster. And so if you still have a mechanical drive, one of the simplest fixes is to upgrade to a solid-state drive. Now, solid-state drives are more expensive by and large. They're also a little bit smaller. They don't have quite as much storage space. However, the speed, the performance boost is so great, and the amount of money that you have to pay extra to get a solid-state drive is getting less and less all the time. So they're becoming affordable, reasonable solutions for hard drive bottlenecks. Now, other concerns that the book raises, they say there's 2 other things you can do. One is to create some sort of mirrored set. I am not a fan of that, mostly because the kind of mirroring they're talking about is mostly taking 2 disks and writing to them at the same time, meaning that some information is on one drive, some's on the other. That's not really mirroring. That's something called striping, which is a problem because if any one of those drives, if you have 2 drives and you're writing information on 2 drives, you have half on one drive, half on the other, one drive fails, you only have half your data, meaning you have none of your data because the other half is not recoverable. So I'm not a big fan of doing that. And even if they are talking about actually mirroring 2 drives and the speed boost you're going to get from that is pretty negligible. It's not something I would recommend. Now, one other thing they did mention is something called moving the paging file. Now, a paging file we haven't really talked about, and for the most part, most of us will not really ever have to deal with a paging file. Windows sets one up, gives it a specific size, and you leave it. Now, paging files are also known as virtual memory. In the past, long time ago, virtual memory was used when you ran out of regular RAM, regular memory, and you needed a little extra in order to run a program, period. Well, RAM is so cheap nowadays and we have so much of it, it's very rare that we're going to run out of RAM for a program. And so virtual memory these days, paging files, don't get used for that. They're now mostly a storage location. It's still memory. It still functions like memory. It functions like RAM that is stored on your hard drive is what it is. And it's used nowadays to hold information that was in RAM for a long time and wasn't used. It gets taken out of active RAM and put into a hard drive, mostly to free up RAM in case maybe we are going to use lots and lots of RAM. We can take stuff that we're not using, take it out of our RAM, put it on the hard drive. And then if we need it, if we're running a program that has to access it, well, we can just take it from the hard drive, slap it back into main RAM, and it doesn't take nearly as long as running an entire program or closing a whole program and then reopening it. So all that said, a paging file is an integral part of the system. The system uses it all the time for internal optimization. But it is on, generally, the C drive, your operating system drive, the drive that all your programs are on. Now, if your system is running slowly and the paging file is being accessed frequently for whatever reason, whether you have only a small amount of RAM or you're running a lot of programs or big programs all at the same time, what you can do is take that paging file and put it on a separate disk, not a separate partition on your disk, but on a whole separate disk. That way, when the paging file is being accessed, it is not slowing down the original disk, which is where your system and your programs are. So when you're accessing a program, you're trying to run it, the paging file, if it's being accessed, has nothing to do with and is not interfering with the original, the other disk and your programs. So that's what they mean by that, and that is a viable thing you can do. Now, I will say it's becoming less and less of a problem, especially with solid-state drives. They're so much faster. Usually, bottlenecks come from other places, but those certainly at this point could still be a significant issue. Okay, so that's for solid-state, solid-state or hard drives. Now, the second bottleneck area, memory, I've just talked about paging file for the last couple minutes. That's one of the chief problems with memory. If you don't have enough RAM, it's going to resort to the virtual memory, the paging file, which is going to be used on the hard drive, which is 1,000 times slower, roughly, than the RAM that you have. So if you run out of RAM and you have to start using a paging file, or you're swapping things between RAM and paging file a lot, your system is going to feel like it is crawling compared to what it's like when you are not out of RAM. So really the only the only practical solution would be to increase the amount of RAM. If you are encountering something where you've determined that RAM is your bottleneck. That said, there are machines that's not possible. Laptops in particular and devices, they have a set amount of RAM hardwired, soldered into the board. You can't just put more memory in. So in those situations, honestly, you tend to sadly start looking at upgrading the device rather than upgrading RAM. If you have the ability to upgrade RAM, however, it is always an option. In fact, usually when people ask me, well, how much RAM should I put on my computer? I say, how much can you afford? And leave it at that. RAM is the single most efficient way to speed up or improve performance on a machine, because lack of sufficient RAM is always going to slow your machine down, and there's not much you can do about it. Now, the other thing is we tend to run out of RAM when one of two things are happening. One, we don't have a lot of RAM, or two, we have a lot of programs running at the same time. Sometimes that's required. I know for my job, I'm often required to have many large programs running at the same time, and so I have to have a good amount of RAM in my computer. But if you are generally doing one task at a time, word processing or working on some sort of maybe a 3D model or doing something else, and you only need one program open, you may be able to be all right with a little less RAM if you change the workflow and only have one or two programs open at a time. So that's another way of handling memory bottleneck issues. Now, third one, processor issues. You've been sitting here staring at a blank Windows screen here for a few minutes while I've been talking. I apologize for that. I'm going to get to a demonstration in just a second. But processor bottlenecks, there's not a lot you can do without changing the processor. Very often, again, going with if you have a device like a tablet or a phone, or if you have a laptop, very often, you can't do that. You can't just upgrade the processor. Sometimes you can, usually you can't. If your processor is slow, your processor is slow. And a new device is generally all you're going to be able to do. If you have a desktop where you can upgrade the processor, that is always an option. If your processor is causing a bottleneck, get a faster one. If you have a single core processor and your motherboard will support it, get a multi-core processor. They tend to run faster because they have more cores in them. Now, not always, because sometimes the programs you're running don't take advantage of multi-core. So processors are kind of the weak link there, because they are the computer themselves. If they are slow, they are slow. But upgrading a CPU, if you can, will help. It's worthwhile to at least look into it, see if it's a possibility. Now, the last bottleneck, networking. Let's just say that there are all sorts of types of networks, and that is an entire discussion all by itself. Mostly, I will say, if you can wire your network, if you can be plugged in, you're probably going to be faster or have less concerns than if it's wireless. Most of us nowadays are using wireless networks all the time on tablets, on phones, on laptops. So it's becoming a thing where we don't have wires anymore, and that's great, but then we lose a lot of control over troubleshooting networking speeds and networking difficulty. But most most network issues nowadays are out of the control of the user, and they're more into the network administrator hands. So I won't really talk about that much. You'll get a lot of that in Net Plus, in A Plus, and in other classes that focus more on networking. Okay? Okay, enough talking. Let's get to work on some of the demonstrations. One of the ways that we can take a look at a quick view to see what our system is doing and see if we can maybe find some bottlenecks is something called the resource monitor. If we go to Start menu and start typing resource, we can go to the resource monitor. Here you see basically a graph. We have 4 separate things that the resource monitor is keeping track of. The CPU, the disk, the network, and the memory. Sound familiar? Yep, that's just what we were talking about. And for each of them, they will have a list of what is happening, what is being used, all the different processes that are running on the processor at one time, and how much percent of the CPU is being used at any given time. Notice we're pretty low because, well, all that's happening right now is we're running resource monitor, and then whatever background processes are happening. And you can see over here, this is a graph that starts extending over time, 60 seconds, where you can see the usage of the CPU. That's pretty low, and that's good. Most CPU, if we're just sitting idle, should be between 0 and 8%, say. If you have a machine where you see the CPU is spiked up at the 70, 80% all the time, especially if you're not doing anything, you need to take a look at what's running in the background. You may have a virus, you may just have a runaway program that needs to be closed, or you may have a really slow processor that needs to be upgraded. So this is where we would look for that. Now, take a look at disks. This is looking a lot worse than it really is because of the size of the graph. If we look at what's happening on it with the disk at any given time, you can see that we've got some spooling going on. This is perfectly normal. We have a spooler, which is a print spooler. We have system, which is the operating system. And they're sitting there generally waiting for things to happen. If you look at the amount of time that we're looking at for disk access and usage, it's at roughly about 0 to 1%. This particular graph, the high end of this graph is something like 1%. So that you're seeing like spikes in amount of data. Like see, it's moving up a little bit to 76K per second. 1% active time, that's perfectly fine. Again, when disk access starts hitting 50, 60%, then you have to start worrying about what's happening. And if you're wondering what's going on, let's take a look down here. Notice network activity. There's almost no network activity until there's a little bit. It spikes for a second, goes down. This is, again, perfectly normal. Now, what's most likely happening, is what we're seeing a little bit of network and then a little bit of disk access, is the computer is running update checks. And I say that because, well, I kind of just turned it on a few minutes ago. It's had a chance to check itself to connect to servers like Windows Update and things like that. And it's checking and talking back to different networks. And then it's doing very brief, short hard drive accesses to see, mostly to read, to see what our status is, to see if my, say, Windows Defender is up to date, if I have any updates for Windows, that kind of thing. That's generally, when you see something like this, that's generally what's happening. Not always, though. I'm just saying that mostly from I know what's on this computer, which is absolutely nothing. And that's about the only thing that can be running right now. The last one down here, memory. So if we look at memory, no, not network, memory. There we go. This is what is being held in memory at the moment. These are services that are running on the operating system right now. And you'll see a lot of them either look the same or sometimes even have the same SVC host. SVC host is a generic naming for a bunch of different system processes, generally system networking processes. So this generally gives us an overview. Let me just take a quick look before I forget to mention this, If you look at memory, there is very little going on. And it should be. Again, nothing's running. You shouldn't see a lot of memory stuff happening. So my system right now is looking pretty safe, pretty normal. There isn't anything bizarre happening. When you start seeing spikes or worse yet, solid blocks of information happening, that's when you know that something is going on. So just for an example, if I leave this up and running and we take a look at network over here, let's say I go to Edge. I'm going to open something up and we're going to see if you start seeing the spike that happens when Edge starts connecting to services, to web pages. Look at that. So as soon as I started, whoa, there was a big spike from Edge. Now, let's say I'm going to go to hp.com. If I go to hp.com, it's going to load the page. And again, we're going to be looking at some serious blocks of information that are happening on the network. Whew, especially while we have video that's loading. That's awful. And I'm going to take a look and see if I can go to support. Because in support, I might be able to get to some drivers. And if I can get to drivers, we can try a sustained download, and you might be able to see what it looks like. Come on, support. Support doesn't want to respond. Notice all the other things are actually moving too. Look, that's the CPU processing something coming from HP's website. Disk access is storing little bits like cookies and other information onto the computer. And memory is handling something actually happening on the computer for a moment, right? So I have a feeling I don't have the proper software to run this web page. I think that's awesome. So let's open up Internet Explorer and see if we can get that going. Internet Explorer. Oh, MATC site. All right. Let's try hp.com again. Again, you can see all the stuff happening up there, which is pretty good. All right. Let me try support here. There we go. Actually move. Software and drivers. And if we go here, we're going to see what happens when I try and download a driver. So let's say I want HP Universal print driver. This should look familiar to those of you who have finished this particular part of the labs. All right, so we're going to say Universal print driver, PCL 64-bit. All right, so if I click on download, this is going to download the file to my computer. So okay, this is fine. And what we should see, it might take a minute, but what we should see is some disk access and some network access that are kind of in tune with each other. Let's see if it actually starts downloading. Oh, there's certainly a lot of network traffic going on. Come on. Yeah, there it goes. Okay, so you can see how right here we have spikes. We have the disk access here. There should be a little more coming over here as we get more network information. And unfortunately, on a virtual machine, there's enough lag that I can't exactly tell. There we go. Okay, I was waiting for that. So network followed by disk spike, followed by network, followed by disk spike. That is an example of when something is downloading onto your computer. Okay? All right, so that took a little while, but at least I was able to demonstrate a little bit of that. And honestly, if we kept this going, because this is downloading so slowly, you would actually see a little bit more of that happening here. So, okay, so that is an example of the resource monitor. This is like a one-stop quick example, quick snapshot of what's going on with your computer. This is the overview. If we wanted to get to more information, each of these tabs would give us basically more detailed information on what's happening on any of these given processes. Okay. Notice here in network, there's different network information that's happening. On disks, we have different things that the disk is checking, both the queue length and the process, and also the different hard drives. Notice nothing's happening on the E drive right now. So, okay, so that is resource monitoring. Let me close that out. The other place we're going to spend a lot of time on, and the next video is going to show this, is the performance monitor. Performance monitor is where we can do a lot of measuring. And we're going to be doing, what I'll talk about in the next videos, we're going to be doing something called a baseline. A baseline is where we get to measure what the computer is like at rest. When there's nothing going on, the computer is new, there's nothing that has happened that we can tell, we are going to measure what's happening. We're going to measure what the general usage is on the computer. The reason we do this is that we want to know basically what is normal. We don't want normal to be a year after the computer has been in service and there's all sorts of problems. Then we don't know what normal. We don't know what this machine is supposed to do. We just know what it's like now. So generally, when you get new computers, it's a good idea to have at least one of them run a baseline and see what the expected usage is supposed to be. And then later on, when someone's complaining, oh, my computer's slow, well, now you can go back to that baseline, to that initial measurement that you had, and see what it's supposed to be, and compare it to with what the machine is currently, and see if there actually is a difference. Because very often, users, and we are all this way, I'm this way too, I know, you get used to speed. You get used to machines running at a certain speed, and then after you've used one for 6 months, 8 months, you start saying, oh, it's slow because you're waiting 2 seconds for something to load. When you used to wait 5 seconds and you thought that was fine, then you got your new computer, it was at 2 seconds, and you thought, oh, this is amazing. And 6 months later, 2 seconds is too slow, and now you need something faster. That happens a lot. And it's human nature, it's the way it goes. So these baseline measurements and then performances that we'll be able to do later with data collection sets, will help us get an unbiased view of what's actually happening on the computer. Okay, so that's enough for this one. I will see you in the next video where we will talk about baselining. I'll show you how to baseline, and I'll show you how to use data collector sets to get information about the current machine.